Welcome, everyone. Thanks for tuning in. Of course, we want to make sure that you're aware of rapidly evolving nuclear energy sector, and the operators face a growing list of new challenges from, of course, things like, an aging infrastructure, which most places are dealing with, to license renewals, to advanced reactor technologies. All of these are challenges that people are faced with today. With these challenges in mind, Element Materials Technology offers a comprehensive suite of testing, inspection, and qualification services that bring safety, performance, and compliance to the nuclear life cycle. Of course, this includes things like a range of critical services such as seismic EMI testing, thermal and radiation aging, harsh environment simulation, valve flow testing, and of course, a lot more. These capabilities are vital for addressing complex needs, including pressure boundary integrity, radiation shielding, and naturally extending the life of key components. And now today, joining us to share his expertise on this subject, drum roll please, it's Greg Mason. Greg is a nuclear professional with 38 plus years of industry experience. He is a graduate of Appalachian State University, and he began working at the Farley Nuclear Plant in 1986, and then Wiley Laboratories, of course, in Huntsville, Alabama in 1991, where he continues to work with Element Nuclear. He is now the director, of course, of nuclear strategic development for Element Nuclear. Hi, Greg. What a pleasure it is to have you here.
Hello, Dean. Thanks for having me.
It is entirely my pleasure. I really do appreciate you taking time to be here with us today. Right off, can you tell us a little bit about your experience and your role with Element?
Sure. So again, as you said, I've been with the Huntsville facility since 1991. So I came there to actually manage the radioactive material program, where I had experience in health physics, and then worked in our valve safe relief valve testing group. Eventually, engineering manager for that safe relief valve test group, and then took on the role that I have now in 2011. So I've been quite a bit involved with the testing aspect, as well as the what I do now, which is uh, bringing in new opportunities and working with our customers all over the world.
It's incredible. You're a busy man. I am certain of that. Uh, so
It keeps
can you
me.
tell?
Yes, we attend probably above 16 or so meetings a year, technical meetings and general meetings within the nuclear industry. We sit on various standard committees within the nuclear areas, so that yes, we stay going quite a bit as well. So.
Well, thank you for your service and all your hard work. Uh, can you tell me what are the key challenges facing the nuclear industry, especially with the aging plants that everybody's dealing with?
Sure. Yeah. The key challenges with the nuclear industry right now is so we'll start with the new plant. The new plants, it really the biggest challenge is the financial cost, um, and getting by that. But the rewards, once you've established the new test new nuclear plants like Vogtle 3 and 4 that have now been operating just over 2 years now, has proven itself, and its capabilities. With the aging plants, it just becomes the over the years of kind of wear and tear that occurs due to the environmental conditions these plants are subjected to. Um, the other part is obsolescence. That's a big part. A lot of these plants were on the drawing board back in the 1960s and 1970s. A lot of those manufacturers are, or not a lot, well, just some manufacturers are not existent anymore, or even manufacturers are around have moved away from equipment that was built at that time. And so that's a challenge in finding replacement equipment or equipment that needs to be repaired, refurbished, and that. So that's generally the biggest challenges that the existing operating plants have. So with that, that's part of what we do. We do help with those and some obsolescence, as well as finding ways to help the plants extend the life of equipment that will give them further service in the safe conditions it was designed to do.
And how does Element test advanced reactor designs?
So the new advanced reactor design, so that's a new thing. The new advanced reactors that are coming along. Uh, we're in the process right now of completing a new test facility that will support the harsh environment testing, which will be at another level compared to the legacy plants that are out there. So right now, what we're doing is building this facility to support that testing that we believe will get started within this year with these advanced reactors. So the advanced reactors, there's positive movement right now with the build of these reactors. So we're at the beginning of providing testing on a we'll call it some cases a prototype where they're looking at prototype equipment and such as that. So that's kind of the stage we're in right now as we continue to move from prototype into actual testing to comply with the standards that are required. We see that will start occurring over the next 5 to 10 years.
And why are fracture mechanics and high temperature testing vital in the nuclear applications?
So those areas are is the vital part of that is the fact that these and then the advanced reactors is the temperatures. Again, there's going to be a lot more temperature. You can expect a higher concentration of radiation just because of when we're talking about some of the advanced reactors, if we're talking about the small modular reactors, the micro reactors, we've put these in a much smaller volume, so they're going to see more radiation, more thermal activities, and so that's an elevated amount of thermal and radiation over a period of time. That now we have to look at those materials. Are those same materials that have been used in traditional plants? Are they going to withstand those rigors for those same service lives of originally 40 years? Now we're looking at 60 years, 80 years. So with that, with these the small modular reactors, those micro reactors, do we need to? Is that service life going to either have to be modified because of more intense uh, exposure because of the proximities, um, or are we going to have to develop those new materials going to need to be developed by those manufacturers and such? So that's the concern with that because those become the base structure and such of these new reactors.
And how do Element's capabilities align with things like the global standards like ASME, ASTM, ISO, and IAEA?
Sure. So our nuclear quality assurance program is based on 10 CFR 50 Appendix B, Code of Federal Regulations. So through that, we work through primarily the ASME and IEEE standards. And so how we stay part of that is we actually, with those test areas that are related to, so the ASME for valves is QME1. We have our engineers that sit on that QME1 standards committee. So we're actively involved in the review and update of those standards. With the IEEE, that's more geared, the ASME being geared towards mechanical type equipment, IEEE electrical equipment. We also sit on those standards committees that are very relative to the work we do and the testing. So we help review and be part of that, part of those groups to make sure those standards continue to provide the security and safety and meet those the national requirements through the Nuclear Regulatory Commission. We also possess ISO 17025, A2LA accreditations, and not just our lab, but across the Element Materials Technology Company with various sites, labs throughout the country and the world, having specific ISO and A2LA accreditations based on the testing that they do.
Now, what sets Element's Huntsville Nuclear Center apart from other labs, let's say?
So, what sets us apart is from other labs within our Element family, mainly with our nuclear QA program. Then, in comparison to other labs that do some of what we do, basically what we have found is we kind of have four different sectors that we do work under it for the nuclear energy community. And we've basically found that we have no competitor that has any more than two of those. So it gives the supply chain from utilities and such the capability to kind of do a one-stop shop for multiple items, create master service agreements to put in place to cover multiple activities, which in turn kind of makes their job a little easier to have one place to reach out to.
Which is nice. It's nice to have one point of contact that really helps an awful lot. Can you share a recent example of Element solving a nuclear technical or let's say a compliance issue?
So we've had a customer in Canada that came to us. They were facing some obsolescence with some equipment, and we worked with our partners at Yokogawa with a new controller that they wanted to customize, specifically customized to use to replace the controllers being utilized in the plant. So we worked with them and Yokogawa to develop this controller to their specifications. So when completed, it could actually go in to the cabinets where the obsolete controllers were. So they could actually just pull out the obsolete controllers and then take the new controller and it would go right into the cabinet without doing any sort of modification. So that's it's already a costly endeavor for a nuclear utility to make a change in design engineering and things like that. But if you can actually keep the that area without having to modify where it's actually being utilized, then that's just an additional cost savings to the utility.
So, how does Element efficiently support utility and OEM qualifications programs while, of course, ensuring compliance?
Sure. So what we do before we start a project is we get with our customer and we work through the project and lay out the how the project's going to proceed, the fabrication of test setup and such. Then and we've also have hired in now professional project managers. And so what they do, they go in and they create these schedules and then provide those to the customers and then become a focal uh, contact at the lab for the customer in order to track the process. Now, at the same time, we also have no problem with our customers being present in person for in-person witnessing and such as well. So when we're working through the project from quotation into receiving purchase order, we have quality standards in place within our program that we need for review. Those reviews help establish the compliance that we're being compliant, not just with the standards, but we're being compliant with the purchase order the customers provided to us. So through that, we'll go through and review that, and at times to also make sure that the customers being compliant. And that'll even go back into the initial discussions where we want to make sure if they're testing to a specific IEEE standard or ASME, QME1 standard, that we will help them to make sure that they are meeting what the intent of that standard has said. So that's part of our just part of our normal process that we go through that. So once the test program is starting, we receive test articles. Then more of our nuclear QA processes step in where we provide. We're going to do receipt inspections. We're going to monitor independently through our nuclear QA staff to monitor calibration records and the activities that are ongoing. They may have hold points until we're completed with the project and we're actually shipping the test article out. So it's through all those steps, through our quality program, through working with a customer that we will maintain that compliance from beginning to end.
That's interesting. Now, what trends are shaping the future of nuclear equipment qualification and materials testing amid the new clean energy standards and growth?
Well, the biggest trends that are occurring, they'll occur with the well, there are two trends. So even with the existing fleet and going into the new advanced reactors is digitizing digital commodities. So the legacy nuclear power plants are very analog in nature. And so there's been a slow movement into the digital uh, assets using recorders, controllers, transmitters, things like that. A lot of that is purposeful because of the design engineering aspects and the cost and time to go through that. Some of that has to do with the fact of how do you protect those services with cybersecurity and those aspects of how do you protect that power plant from outside sources, trying to reach into it via wireless technology and things like that. So that's part of, but that is the growth, and a big part of that growth is the digital technology. Um, the other part with just advanced reactors in general is now you're starting to look at new materials, new material development. Um, there have been continuous, now we have, there are EPA, various EPA standards and such that existed that were grandfathered in for things, originally that had asbestos and other chemicals and things like that. Now, you're building to the new, all those new codes that are, not part of the NRC codes, but they're part of our other regulatory codes that are out there for the safety of and persons and the environment. So now you have to adapt in, look at materials, new equipment. And as I spoke to earlier, now we're also looking with the advanced reactors at new environmental conditions that this equipment's going to be subjected to, higher temperatures, potentially higher radiation levels, and such. So those are the challenges that are facing, and actually, the legacy and the new designs.
And why is it critical for nuclear operators and manufacturers to work with an accredited lab like Element?
Right. So yeah, and we actually have the first lab in the U.S. to receive the IEEE ICAP certification, which is an additional level of certification and auditing that we've gone through. So it's critical for manufacturers and such to come to a facility like ours to do their qualification work, because that paperwork will be infinitely held uh, and scrutinized and audited against by regulatory bodies and other. So it's imperative that the work we do, our quality system that backs it up, our accreditations, that all of that is spelled out and in line with the end product, which is us issuing a test report, a certificate of conformance that we say that we are meeting all of those requirements. And that's what, at the end of the day, what the customer is looking for, so that they can install that equipment and have the assurity that it will perform its safety function if it's ever needed.
Gotcha. Well, Greg, we're just about out of time here. I want to thank you for being here today.
Thank you. I appreciate the time.
And a special thanks, of course, to you, Greg, for sharing your expertise in an aging infrastructure challenges, and of course, our next generation reactor technologies. And thank you for your time today and for exploring nuclear testing excellence with Global Spec and Element. We invite you now to take your next steps with Element.